In this video, we're going to talk about exponents. So just to kind of give a brief crash course about them, exponents are a type of shorthand for multiplication, specifically if we're multiplying the same number over and over again. So for example, we have 6 to the third power. This would translate into 6 times 6 times 6. Before we go any further, I also want to talk about kind of the anatomy of what an exponential expression contains. So, for example, the value of 3, this is, if you haven't already guessed it, is going to be your exponent. And then the value of 6 is going to represent the base. Now that we have a basic idea of the structure and definition of an exponential expression, we're going to go ahead and investigate some examples of raising an integer to a particular exponent or a particular power. So the top two problems in Navy are probably very familiar to you. So for example, you might look at 3 squared and you're going to know right off the bat that this is 9. And again, just as a refresher, you could expand that out. So when you see 3 squared, you could say that that's 3 times 3, which we probably know very quickly is 9. So likewise, if we did 10 to the 5th power, if we wanted to, we could expand that out and basically write out a multiplication of 5 tens. And then this would end up giving us 10,000. For the bottom 4 problems, I want you to notice the difference between the ones that I have written in blue versus the ones that I have written in green. Notice that the ones written in blue contain parentheses. So, for example, -4 squared. What we are doing here is we want to square the entire -4. So, in other words, that negative is included in that squaring. So, if we were to expand that out, this would be -4 times -4. And again, a negative times a negative would give us a positive 16. So notice that the next problem, -5 to the third power, is slightly different than the previous one that we just worked on. Now the exponent is odd as opposed to even. We'll get a better understanding of what this means if we expand it out. So -5 raised to the third power would be -5 times -5 times -5. So one thing to note, let's do this in parts. We'll do -5 times -5. A negative times a negative gives us a positive 25, and then we're going to multiply that with the remaining -5. This would then give us -125. So as we can see here, even when we are raising that entire negative number to an odd power, we're going to get a negative result, where in the last problem, when we take an entire negative number and raise it to an even power, we get a positive result. So now with the last two problems, we don't have parentheses around these negative numbers. So what this tells us is that it's only the 7, for example, that's going to be raised to the second power. So another way of looking at this, or another way of rewriting this problem, would be to actually say this is -1 times 7 to the second power. So what I'm essentially saying here is that the negative just hangs out and kind of waits until you're done evaluating that exponential expression, and then you're essentially multiplying it by a -1. So we're using our order of operations here. So this could be -1 times 7 squared is 49, which will then give us -49. Now, keep in mind that the steps that I've shown you here were really more so just to help explain what's happening. You probably are not going to be expected to show all of these steps in your work. And then likewise, if we are working with -2 raised to the 7th, again, I don't have any parentheses around that -2, so it's just the 2 that's being raised to the 7th power, and the negative is just going to kind of hang out until we're ready to use it. So we could write this as -1 times 2 times 2 times 2 times 2 times 2 times 2 times 2. The resulting solution here would be -128. Now it's your turn. Go ahead and take a moment to pause the video and work on these 3 examples. When you press play, we'll review those solutions. For the solutions, I've gone ahead and expanded out my work just so we can see the finer details. So for 8 squared, we should have gotten a solution of 64. For a negative 8 squared, again, noting that there are no parentheses containing that negative 8, we would get a negative 64 as our solution. And for our last question, the negative 8, the entire negative 8 being squared, we would get a positive 64. For our next set of examples, we're going to be looking at raising a fraction to an exponent. So one way that we could approach this problem would be to give the exponent to the numerator and to the denominator. So in other words, 2/3 to the 4th power could be 2 to the 4th all over 3 to the 4th. So we can kind of get a better idea of this if we expand this out instead. So 2/3 to the 4th power would be 2/3 times 2/3 times 2/3 times 2/3, or in other words, this is 2 to the 4th all over 3 to the 4th, knowing what we know about multiplying with fractions. And this would become 16 over 81. For our second example, notice that we are taking a negative number and we are raising it to an even exponent. Also notice that that negative number is contained within a set of parentheses. So remember, one way that we could approach this would be to expand it out, just as we have done before. So this would be negative 1/6 times negative 1/6. This would give us negative 1 times negative 1 is a positive 1 all over 6 times 6, which is 36. We could also use the same tactic as was demonstrated in the first example on this slide. So this could become negative 1 squared all over 6 squared. Negative 1 squared would be a positive 1, and then 6 squared would give us 36. So maybe you are asking yourself, well, how did I know that the negative belonged to the 1 and not to the 6? Or maybe the question was, how come the negative doesn't go to the 1 and the 6? Just to clarify, when you have a negative in front of a fraction, it's either going to be attached to the numerator or it's going to be attached to the denominator. You get to decide which one. Just make sure that that negative does not go to both numbers. So maybe if you wanted to, you could instead write this as 1 squared all over negative 6 squared. And again, we'll see that we still get 136. Now it's your turn. Go ahead and pause the video, work through these problems, and when you're ready, press play. So for our first problem, 2/5 squared, this would become 4/25. And then for our second problem, the entire negative 3/4 squared, wherever you decide that that negative should go, meaning in the numerator or the denominator, we see that our solution will become 9/16. For our last set of examples, we're going to take a look at square rooting a fraction. Before we begin, remember that a square root is basically a special notation for a fraction exponent. So in other words, the square root of 64/9 is saying the same thing as 64/9 raised to the 1/2 power. So this is why you're seeing it in this exponents video. We can use what we learned in the previous set of examples to help us evaluate these square root expressions. So, for example, the square root of 64 over 9, we could write this as the square root of 64 all over the square root of 9. So in other words, I can break that square root between the numerator and the denominator. And then evaluating further, we can say, well, I know the square root of 64 is 8, and I know that the square root of 9 is 3. So here is my solution. Likewise, we can do the same thing with the example below. So the square root of 13 over 81 becomes the square root of 13 all over the square root of 81. So I deliberately did pick a problem where I know that 13 is not a perfect square. So I'm just going to leave my answer as the square root of 13. There's nothing that I can do to further simplify it because 13 is a prime number. But I do see that the square root of 81 is a perfect square, and that would become 9. So here is where I would leave my solution. As always, you get a chance to work on these and practice them. Please go ahead and pause the video to work on these two problems. When you're ready, press play, and we'll review the solutions. For our first example, we have the square root of 23 over 100. We can rewrite that as the square root of 23 over the square root of 100. Again, the value in the numerator is a prime number. In other words, we cannot break it down or simplify that square root any further than it already is. So we're going to leave it as the square root of 23. However, the square root of 100 becomes 10. For our second example, we have the square root of 16 over 144. One way that we could approach this problem would be to break this into the square root of 16 over the square root of 144. Both of those values are perfect squares, so that would become 4 over 12, which we could simplify down further to become 1/3. Another way that we could approach this problem is you might have noticed, or you may have tried, to reduce 16 over 144 first. If you did, you would see that 16 over 144 reduces to 1/9. Again, we could rewrite this as the square root of 1 over the square root of 9, which will then give us the square root of 1 is 1, and the square root of 9 is 3. So our answer, again, would be 1/3.